Hello, everyone, and welcome to the Data Platform Summit. I'm Sanil Mhatre, and today we will be talking about topic modeling. It's a field of natural language processing, and I'm really excited to be here to share this content with you. Uh, while this session is a recording, I am available here for a live Q&A with you. So please feel free to interact with me during the live Q&A. Let's get started. We are going to deep dive into natural language processing today with a discussion about topic modeling. Introduce myself. I'm Sanil Mhatre. I'm the lead data scientist at Worldwide Technology. We are a technology and services provider located in St. Louis, Missouri, in the US. I'm a data scientist with extensive background in data engineering, business intelligence, database administration, and enterprise architecture. I have worked with Azure, AWS, Google Cloud platforms. I have worked with several databases, SQL Server, Oracle, Snowflake, to name a few. And I also enjoy being an agile coach, mentor. I enjoy speaking at conferences and user groups, as well as blogging. You can find me on LinkedIn. You can also find me on Twitter. My Twitter handle is SQL Super Guru. I also publish technical articles on Redgate Simple Talk. Uh, you're welcome to look at my articles on Simple Talk as well. Let's jump right into our agenda for today. We are going to first talk about topic modeling. What is topic modeling? Why would you want to do this topic modeling thing? And if you choose to do topic modeling, how do you go about doing it? Next, we'll jump into how do you prepare your data to feed into a topic modeling algorithm. Next up, we'll look at how do you train your topic model and how do you evaluate your performance. And last but not the least, this is the most fun part, where we look into how do you infer the output of your model? How do you derive meaningful insights from the output that your machine learning model is generating? All right, so let's start with where does topic modeling fall in the landscape of natural language processing technologies? What exactly is this thing called natural language processing? Natural language processing is simply a set of machine learning driven processes for deciphering human language text data using software. There are several techniques that encompass the universe of natural language processing. Some of them include sentiment analysis, named entity recognition, text summarization, aspect mining, and last but not the least, topic modeling, which is the focus of today's discussion. So what exactly is topic modeling? It's an unsupervised machine learning technique. You may have come across the terminology of supervised and unsupervised machine learning techniques. Supervised machine learning techniques are where you might train your model and teach the model how it should learn. A good example might be classification techniques, where you want to teach your model to identify pictures of cats or pictures of dogs. You might have to train your model by showing it hundreds of thousands of pictures of cat and hundreds of thousands of pictures of dogs to help it learn how do you identify a dog or how do you identify a cat. With unsupervised learning, with unsupervised machine learning techniques, you don't really know what exactly you might be looking for. and you don't go about telling the model how it should learn. You don't provide it with a training dataset. The model learns on its own. It sounds a little bit like black magic at this point, but it will get a whole lot clearer as we deep dive into it during the course of today's discussion. At a very, very high level, how does the topic modeling algorithm work? It represents a text document as a collection of topics. Think of it like a book. A book is a collection of chapters. On similar lines, a topic modeling algorithm will look at a text document as a collection of topics. It will try to find relationships amongst the data points it collects in that text document. The most popular implementation of topic modeling can be found with latent dialect allocation algorithm. It's a probabilistic modeling technique. The specifics of how LDA works at a very high level is that it treats the text document as a distribution of topic. So previously we talked about the fact that a text document is a collection of topics. Distribution of topics simply adds another attribute to it. Not only do you know how many topics are encompassed in the document, but you also know the weightage. Topic 1 maybe composes 50% of the document. Topic 2 is 20%. Topic 3 is 15%, so on and so forth. So that's what we mean by distribution of topics. And then the topics themselves are simply a collection of words, a cluster of words. Let's take a quick look at the visual representation of an LDA algorithm. All the way on the left-hand side, you start with a collection of documents. A document is simply a text file. It can have large volumes of text. You can have one or more text files. That's the collection of document. You feed these collection of documents into an LDA algorithm. It will do its magic. The colored circles on the right-hand side represent the 3 topics that the LDA algorithm has identified. The red circle, the yellow circle, and the black circle are the 3 distinct topics. Within these colored circles, you'll find there are gray dots. Those dots represent a word. So, a topic is simply a cluster of words. The bar chart on the bottom right hand side of the slide talks about the distribution. So not only do you know that a topic is a collection of words, you also know the frequency of each and every word that came together to form that topic. Word 1 appeared 10 times. Word 2 appeared about 5 times. So word 1 has twice the weightage. Then word 2. All right. So at a very high level, we talked about what is topic modeling. Let's jump into why do you use topic modeling? It's a whole lot more fun to learn about something if you know how you're going to use it. So that's what we are going to cover now. There is definitely a need in the industry for deriving meaning and actionable insights from large volumes of text. Think about your call center transcripts. Think about your doctor's transcripts, medical transcripts. Maybe look at social media posts, reviews online like Google reviews or Yelp reviews. All of these things generate large volumes of text, and there is a burning need out there to extract some meaning, extract some actionable insights from these large volumes of text. Some of the natural language processing techniques like text summarization, aspect mining, keyword and key phrase frequency techniques have certain limitations. As we dig further into today's presentation, we'll take a look at what exactly those limitations are and how topic modeling can help overcome those limitations. Topic modeling is relatively easy, it's reliable, and it's a popularly used technique in the industry. So there's a lot of support available in the industry for performing this technique, for troubleshooting any issues that you might run into. A couple of examples about discovering valuable business insights with topic modeling would be, let's say you have a customer complaint database which has transcripts of the calls that your call center has received. You might also have chat text in this customer complaint database. And from all of this text, you might want to identify on a regular basis what are the top 5 customer complaints. Topic modeling can help you do that. You might ask, what's the value of identifying the top 5 complaints? Why, if you know what your customer is complaining about, you might be able to invest some effort into solving those problems proactively. Maybe your product, maybe your app needs a feature that is causing customers to complain. Uh, to fix those complaints, you might need to update that feature or add a brand new feature. If you don't know exactly what your product could benefit from improving upon, you have survey responses. A lot of surveys these days ask for open-ended responses. You can simply type whatever text you can want to. Topic modeling might help you identify the top 3 suggestions for improving your app, for improving your product, service, or process based on survey responses. Now that we know how topic modeling is useful in real life, how topic modeling has business value, let's quickly jump into the high-level topic modeling process. So once you have decided to take on a topic modeling project, you would want to start with collecting your data set, your documents, your text data. They might be sitting in a database, they might just be raw files, whatever that format is. You first load that data into a data science platform of your choice, and then you go about cleaning that data. Then you perform a process called tokenization. Tokenization is simply breaking up your text into individual tokens. These tokens can be a single word or a collection of words. Once tokenization is done, you eliminate stop words. Stop words are simply the most commonly occurring words in any language that don't have a lot of meaning. Words like a, and, the, things like that, prepositions, conjunctions, you eliminate the stop words. You create n-grams. N-grams are basically just unigrams, which is one word, bigram, which is 2 words that occur together, trigram, 3 words that occur together. So n-grams is just the generalized term for words that occur together. You then perform lemmatization, which is reducing the word to its root. Don't worry too much about understanding the details right now. We have slides further which will go into the details of each and every one of these terminologies that I'm talking about over here. After lemmatization, you create a dictionary and a term frequency document corpus. What exactly is that? We'll look into in some of the following slides with a demo. All right, so now that all of Once this data prep is complete, you go into the iterative process of training, building your topic model. So you build your LDA model. Next, you look at the model performance metrics and you look at the output generated by the model. By evaluating the metrics as well as reviewing the output, you might come to the conclusion that your model needs to be worked upon some more. So that's an iterative process where you keep retraining your model until you're happy with the model performance metrics as well as the output. How exactly do you evaluate the model performance metrics? How do you interpret the output? We'll look into those details in subsequent slides. After several iterations, once you're happy with the model performance metrics as well as its output, you finalize the model. At this stage, you would want to focus on interpreting the output of the model in a format that makes sense to people. This step typically involves human interaction, and we would want to label human readable topics coming out of the LDA output. How exactly are we going to do each and every one of these steps is the remainder of today's discussion. The rest of today's discussion is not just slides, but we'll be looking at a live demo as well. So let's jump right into it. The demo use case for today is real life data from my organization. Our company's IT department works in an agile fashion. Our agile office every quarter will evaluate the health of each and every team in IT. They do this by simply asking one open-ended question to all the team members in the IT department by sending out a survey. That question simply asks, how do you feel about your team's health in this quarter? It's sent out at the end of every quarter, and you are encouraged to type a text response, your thoughts, your feelings about your judgment on the health of your team. That's the data set we are going to use today for the demo. We have 9 teams, 3 managers, and it covers 4 quarters. So it's 2 years worth of data. We have a total of 300 responses. This raw data set is in Excel, and I'll show you the Excel file in just a minute. For privacy and confidentiality, I have eliminated all of the PII and NPI information from the dataset, and it's all kosher and good for the demo. But outside of this kind of scrubbing, it truly is real data. So here's the Excel file for the raw data. You have the period field, which gives you the year and the quarter. You have the manager name, the team name. The manager name and team names have been de-identified. And then you have the actual response. You'll notice some people are pretty verbose with their responses. Some people, not so much, just a single word response. Okay, so let's jump back to our slide deck and look at the demo environment. I'm using Anaconda, and within Anaconda, I'm going to launch a Jupyter Notebook Python. The packages I'm using are Spacey for lemmatization, NLTK for stop words, Jensen, just the core package for topic modeling, PyLDAViz, it's an interactive package for web-based visualizations, and some of the additional libraries that are typical in any data science project in Python is Pandas, NumPy, Matplotlib, and word cloud over here for visualizing the word frequencies. So let's go into the demo. On my screen, you can see the Anaconda navigator. Anaconda is really good for data scientists to use on their laptops for their development environment. I'm using the personal edition, which is free for download and use. Uh, as a data scientist, I find it tremendously useful because I don't really have to worry about installing a lot of software, installing the packages. All of that headache is typically managed very, very well by Anaconda. All you have to do is install Anaconda and then launch your Jupyter notebook, and you're good to go. So let's launch the Jupyter notebook over here. Click on this launch button. I have already done that to set up the demo. Once you launch the Jupyter notebook, it will open in a browser of your choice. So that's what you see on my screen now. Jupyter notebook interface is open. I have a Jupyter notebook already created, topic modeling. So let's click on it and open the Jupyter notebook. Okay, so the first thing we are going to do is install some of the packages and import the libraries that we need to use in this exercise. We already talked about which packages we are going to use, so I'll not walk through the code step by step. I'm simply going to run the code first. Cell here in this notebook installs Jensen. The next cell in the notebook imports the various libraries that we looked at. All right, so that's done. Next step is to import the raw data file. The Excel file that I talked about, we'll import that Excel file using pandas.read Excel function, and this will create a data frame for your Excel file. We'll then filter this data frame to only keep the one column that we care about, which is response text. Next, we are going to apply a few transformations to clean up this data. We'll convert everything to lowercase and we'll replace all the non-alphabet characters with just a white space. So let's run this cell, and it runs pretty quick. So the first output you see is from the first print statement. You'll notice the format here is exactly what you see from the Excel file. The next output here is after the cleaning has been done. So we now only have the response text column. Now that a little bit of data cleaning is done, we'll generate a word cloud. A word cloud is a visualization that shows you the frequency of every word that occurs in your body of text. You'll notice here some words have a much larger font than others. The larger the font of the word, the more frequently that word has appeared in the body of text. So the text document that we looked at are survey responses. The word cloud generated from this text document tells me that the word together seems to have the highest frequency. The word fun, well, works, and teams seems to have the next highest frequency. At a very, very high level, what this is telling me is potentially the teams seem to work well together and they seem to be having fun. They seem to be constantly learning, things like that. So overall, a positive feeling. Can you interpret anything else from this word cloud? Probably not, right? Yeah. So that's some of the limitations of these frequency techniques. You can only get some very, very high level directional insights, nothing deep, nothing meaningful, nothing actionable. So this is where topic modeling really shines. At the end of this demo, we'll compare the output of topic modeling against the word cloud. All right, so we'll do a little bit of back and forth between the slides and the Jupyter notebook as we cover each and every section over here. We talked about the demo word cloud section. We looked at the demo. Next one is tokenization and stop words. Tokenization is simply the process of separating a body of text into smaller units called tokens to apply natural language processing algorithms. It's a pretty standard step in natural language processing. Tokens can be single words, so unigrams, or they can be bigrams, just two words, trigrams, three words. So in general, they can be phrases, which are also called n-grams. Or you could even go to the other extreme, and every character could be a token. Not terribly useful, but you could do it if you wanted to. Next up is stop word elimination. We already talked about stop word elimination previously. These are the words that don't really add a lot of meaning to your text, and it's best to remove those low value words. That's called stop word elimination. You filter them out before further processing. Um, we are going to use the standard stop list. NLTK provides a standard stop list. Most popular packages will allow you to customize or extend the stop list. Next, we'll look into n-grams and lemmatization. N-grams are basically more than one words that come together, and that might change the meaning. So let's say the word good by itself means something. The word not by itself means something. When you put these two words together, not good, now the meaning of the word good has completely changed. It's opposite. Not good means bad. So if you were making some assumptions or making some interpretations by looking at these two words separately, you may reach the wrong conclusion. So it's optimal to look at these two words together. So that's why you want to look at bigrams. That's why you want to look at trigrams. Lemmatization is simply the process of converting words to their roots. It's very, very useful to reduce the number of unique words that you are feeding your machine learning model, and lemmatization plays a key role over here. A good example would be words like walking and walks. Walk, singular, is the root of these two words. So, as the output of a lemmatization process, wherever these two words, walking and walk, are found in the text, your lemmatization section will replace them with just one word, walk. Let's take a quick look at the Jupyter Notebook code, and let's perform all of the steps that we first talked about. Right. So first, we are going to convert all of the data values to a list, and then we are going to eliminate stop words in this section. So let's run this section and finish those steps. Next, we are going to define some of the functions to perform stop word elimination n-gram generation, and lemmatization. The first function removes stopwords. The second function generates bigrams. The third function generates trigrams. And this last function performs the step of lemmatization. So let's run this cell to create all of those functions. And in the next cell, we are going to run those functions. Let's execute the next cell and apply all of these transformations. So eliminate stopwords, generate bigrams, and then lemmatize the data. All right, so these things are now done. The next step is to create the corpus and the dictionary. So, why do you create the corpus and the dictionary? Well, it's needed as inputs to the LDA module. That's why. A dictionary is nothing but a collection of the lemmatized words from your text. It's just the fancy way of saying that it's the list of all the unique lemmatized words that appear in your text, and then an ID is assigned to each and every unique word, a numerical ID. Corpus, the word is just Latin for body, and it refers to a collection of text. In this case, the corpus is the term document frequency corpus. What it means is from the dictionary, we have a unique list of words. We also now need to know how many times did each and every one of these words appear in our text document collection. So that's what the corpus is. The unique ID, and then how many times did the word that matches up with this unique ID show up. These two are going to be inputs to our topic modeling algorithm. So let's go back to the Jupyter notebook real quick and create the dictionary as well as the corpus. So let's run this cell and perform the steps of creating the corpus. Out here, I want to show you the human readable output of the corpus. You'll notice it's a list of unique lemmatized words and then its frequency. So the word process appears one time. The word product appears 2 times. You get the hint, right? Okay, we are now very, very close to actually calling the LDA module. So that's the next step. Let's call the Gensim LDA module. We already talked about the fact that the 2 key data inputs to the LDA Gensim module are the corpus and the dictionary. We created those 2 inputs. The next input is a parameter called number of topics. This is where you tell the algorithm, hey, Gensim LDA model, can you generate 2 topics from this body of text? Mind you, you don't really know at this point if 2 is the right number of topics or not. Maybe your text has 2 topics, 3 topics, 4 topics, we don't know. So we start with 2 topics. So you set the parameter to 2. You look at the output. If you're not happy with the output, you change the parameter to 3 and reiterate. You change it to 4 and reiterate until you're happy with the output of the model. Okay. So the LDA model library, the module, is going to generate its output in the form of a topic ID. It will give you the keywords for every topic ID, and it will give you the importance score for every keyword within the topic. So how dominant is a particular keyword within the topic? Let's go into Jupyter Notebook and take a quick look at it. So building the LDA model now. gensim.models.lda model. Corpus is one of the inputs that we generated previously, the dataset. ID to word is the term frequency document that we had generated previously. That's our second data input. Number of topics is the parameter that we will need to change and rerun the model. The remaining input parameters, I highly recommend just leaving the defaults the way they are. The next set of code simply prints the output. Let's run this. Running. This might take a few seconds and you'll see the output over here. Two topics. Topic number 0, topic number 1. And you'll see the list of terms for topic number 0 along with the importance score. So the term team has the highest importance score in topic 0 and its importance is 0.038. The word green has the lowest importance in topic number 0 and its importance is 0.01. For topic number 1, the word team also shows up, but its importance is much higher. And the word with the least importance in topic number 1 is lot, and its importance score is 0.009. It's pretty low. All right, is this model a good model or not? We don't know yet. So some of the ways that you can evaluate if the performance of the model is really good is using key performance indicators, metrics. Perplexity and coherence are the two metrics that we'll use. So let's quickly talk about what are these metrics. Perplexity is a measure of how surprised your model is when it encounters new data that it has never seen before. Lower the value of perplexity score, the better, because you want your model to be less confused. You want your model to be less perplexed when it sees brand new data that it may have never seen before. Topic coherence, the definition, is pretty much in alignment with the English definition of the word coherence. A set of facts or a set of statements are said to be coherent if they support each other. In the context of the output of topic modeling, topic coherence is simply a measure of the similarity between the various words within the same topic. Remember how we talked about the fact that a topic is simply a cluster of words. Are those words coherent or not is what the coherence score measures. So, higher the value of coherence score, the better your model is. Alright, so two things to remember. Perplexity score, lower is better. Topic coherence score, higher is better. Let's calculate these scores for our topic model for two topics. So let's run this piece of code and it will calculate the two scores. Alright, so we have these two scores generated. Is this good or not? Once again, we don't know because these scores in isolation don't necessarily mean anything. We now have to rerun the model with a different parameter and see how these scores change. Before we do that, I also want to show the PyLDA Viz visualization that helps you visualize the output of a topic modeling algorithm. So, why do you want to do this? Perplexity and coherence scores are a good statistical measure, but they may or may not always lead to topics that make sense to us humans. Those topics which are at the ideal intersection of perplexity and coherence score may not really make sense to us humans. So you look at the output as well. And the best way to visualize the output is a chart called the intertopic distance map. It's an interactive web-based visualization where every topic is represented as a bubble on the screen. The size of the bubble represents its importance in the whole body of text. And what you are looking for are large bubbles that are scattered far apart on your map and they are not overlapping. That represents a really good topic model. This will start making a whole lot more sense once we look at the output. So let's visualize the output of a topic model for two topics. This might take a few seconds to come back, and it has come back. All right. So we have two bubbles. Each bubble represents a topic. When you click on bubble for topic 1, you'll see the bar chart on the right hand side, which is a collection of words that make up this topic. When you click on bubble number 2, you'll see the bar chart has changed and it's showing you the collection of words that made up topic number 2. You'll also notice a percentage composition over here. So topic 2 is 41.8% of all the tokens. Topic 1 is 58%. So topic 1 definitely has much more weightage in your whole body of text. All right, so let's go to the next iteration. Let's retrain this model with number of topics equal to 3. So this is the only change between the previous iteration and this iteration. Number of topics parameter is now changed from 2 to 3. Let's look at the intertopic distance map for 3 topics. You'll notice this map looks really nice. There are 3 large bubbles and these bubbles are spaced pretty far apart. You'll notice the weightage of every topic as well. Okay, is this good? We don't know yet. We have perplexity score and coherence scores. I'll make a note of these and we'll compare them with our previous iterations. But just make a note of this for now. Next thing we are going to do is rerun the model again by changing the value of the num topics parameter to 4. Once again, perplexity score is generated, coherence score is generated as well. We are making a note of these and we are looking at the intertopic distance map. And here we have a gotcha. You notice the bubbles for topic 1 and 2 are overlapping. This is not an optimal model because we talked about the fact that what you're looking for is that on the intertopic distance map, your bubbles should be large and they should be spread apart and they should not be overlapping. So this tells us that we have overshot our num topics parameter. 3 seems to be the ideal number of topics in our body of text. So at this point, I'm going to go back to my slide deck and we'll look at all of these results compiled together. Okay, so the table at the bottom shows us for number of topics equals to 2, model perplexity score, topic coherence score, and some notes about the intertopic distance map. You'll notice as number of topics has increased from 2 to 3 to 4, the model perplexity score has become more and more negative, which means that it has decreased, which is a good thing. That's what we want. The topic coherence score has become more and more positive. It has increased, which is also really good. That's what we want. If you were only looking at the model perplexity and coherence scores, you might feel that 4 is the optimal number of topics in this body of text. But that would be a mistake because when you look at the intertopic distance map, you notice that the circles, the bubbles for topic 1 and 2 are overlapping, which means that your text, your collection of documents, doesn't really have 4 unique topics. It only has 3 unique topics. So when you look at all of these things together, you can safely conclude that the optimal number of topics in this body of text, in this collection of documents, is 3. Let's now go with labeling those topics. All right, so how do you label the topics? This is where your subject matter expertise, your common sense as a human comes into play. The machine can't really label the topics for you. So when you click on the bubble for topic number 1, on the right hand side, you see the list of words that form topic number 1. You see here I'm clicking on topic number 1. It's 43%, and here are the top 30 words. I'm taking only the top 10 words and making a note of it. I'll do the same thing for topic number 2 and topic number 3. That's what you see summarized on this slide. By looking at the top 10 words for topic number 1 and applying some of my subject matter knowledge about this survey, I come to the conclusion that the appropriate label for this topic might be overall team health feels good. It's positive, it's green. The words inside the brackets are my filling the blanks. These are not the words that came out of the LDA model. These are my filling the blanks to compose a meaningful sentence. You do the same for topic number 2, and we can infer that great work, good support, and lot of fun seems to be the second most prevalent topic. The next topic that comes out of your LDM model from this body of text seems to indicate that there is some room for improvement. All right. So this is how you go about labeling the topics that you infer from your LDA model. Next, let's compare the word cloud with the output of the topic modeling algorithm. On the left side, you'll see the word cloud. We had generated this word cloud towards the beginning of our demo. And the word cloud seemed to indicate that the word together was the most frequent, followed by the word work, fun, well, and theme. These words have a positive connotation. So you might conclude that the teams work well together, they have fun, overall positive feeling, but not much else. On the right hand side, let's look at the topic modeling output. By compiling all of the topic modeling outputs and the inferences, plus the labels that we attach to the topics, we can say with a good deal of confidence, summarize all of this to your stakeholders. In this case, it's the IT leadership team. That there seems to be a consensus amongst the survey respondents that the overall health of the teams is good, it's positive. And 43.3% of the survey responses seem to indicate that. Next is about a third of the survey responses seem to indicate that the teams are very supportive of their team members. It's a positive work environment for teamwork, and the teams seem to have a lot of fun working together. The next insight for your business stakeholder group is about 20% of the survey responses seem to indicate that there's some room for improvement. So while everything is mostly good, there is some opportunity for improvement. And this is where your IT leadership group might need to dig a little bit deeper, try to find out what are people not happy about, what are their suggestions for improvements. The next point that I want to briefly cover is automation. So you notice how we manually change the parameter number of topics, its value from 2 to 3 to 4, and reran that cell. Uh, it can be quite tedious if you had to do this more than 3 or 4 times. So a potential way to automate this might be to write a loop and generate the pi-LDA viz plot, which is the intertopic distance map, and use that to find the optimal number of human readable topics. Another option for automation might be to use a package called the LDA Mallet. Mallet is an open source toolkit for natural language processing, specifically for LDA based topic modeling. Uh, Covering these automation techniques is out of the scope of today's discussion. So, with that, I'll wrap up today's conversation. Uh, let's summarize what we talked about today. We introduced the natural language processing technique of topic modeling. We looked into the data science environment to perform topic modeling. We looked at the data cleaning steps and the data preparation steps that are necessary to work with LDA for topic modeling. We did the iterative process of model training and identifying the optimal number of topics in your body of text. Once you have found the optimal number of topics, we talked about how to label those topics, how to interpret that output into a human readable form, into something meaningful and insightful for humans. We compared the deep insights that come from topic modeling with some of the shallow outcomes, the shallow analysis that techniques like word cloud generates, and that helps us justify the investment into some of these deeper, insightful techniques like topic modeling. And lastly, we briefly touched upon how your business stakeholder uh, can be presented with meaningful insights that come out of a topic modeling exercise. It's a practical use of natural language processing. Some of the references for the material covered in today's discussion are available over here. Thank you, everyone, for joining me today. Special thanks to our sponsors, including Microsoft. And thank you, all of you, for being an awesome audience today. I am available for Q&A, so you are welcome to reach out to me and ask your questions. Thank you, folks. It was lovely sharing topic modeling with you. I hope to hear from you during the Q&A section. Take care. Bye.